Assalamualaikum dan selamat sejahtera. Kami daripada kumpulan 5 akan membentangkan tajuk workshop teknologi chapter 7 iaitu upwelding. Saya Muhammad Nazim Syakirin bin Zahari, 15 DKM 21F1049 dan rakan yang lain Syazrin Natasha, 15 DKM 21F1043, Al-Hafizi, 15 DKM 21F1047, Tirun Bank Katishrum 15 DKM 21F1051 dan last sekali Ikmal 15 DKM 21F1086.
Okay, my name is Al-Hafizi. Today I want to talk about principles GMAW. Okay, what is MIG welding? MIG welding stands for Metal Inert Gas or Gas Metal Arc Welding, GMAW. It's a welding process in which a consumable metal electrodes is used to produce the electrode arc to join the metal piece together in the environment of a shielding gas. Shielding gas protects the welding from atmospheric contamination. Constant voltage direct current power source is used to produce the arc. Okay, this welding was first invented in the year 1914 for welding aluminium and other non-ferrous materials. This process can be semi-automatic or automatic. It uses argon and helium as the shielding gas because these two are most economical and inert. The metal transfer in MIG welding takes place in four primary ways, and these are globular, short-circuiting spray, and fast spray. Each method has its own characteristics, properties, advantages, and corresponding limitations. Working principle. The MIG welding process is based on the principle that a consumable metal electrodes is to produce an arc in between the metal electrode and the workpiece. The arc so produced creates a large amount of heat, and this heat used to join the two metal pieces together. The whole process takes place under a shielding gas, argon and helium, to prevent the weld from atmospheric and contamination. The GMAW or MIG welding process uses four primary methods of metal transfer. Okay, first, globular transfer. Producers of a Roger weld bit due to metal droplet size and the propensity for splattering. Second, short-circuiting. Word as the name implies. The welding wire contacts the basement metal in a quietly repeated tapping method many times per second. Third, spray transfer. Transmit tiny droplet of molten metal in such a steady fashion that maintain a steady contact arc welding during the process. Fourth, fast spray is very similar to spray transfer but periods because of the start of delivery. This process can be used on a wide variety of metal plate thickness and it almost all welding position. Okay, next. What is a GMAW welding machine? Gas MIG welding uses a continuous solid wire electrode that travels through the welding gun, which is gas metal arc welding, also known as metal inert or component by shielding gas to protect it from contaminants. What type of welding machine is used for MIG welding? MIG or gas metal arc welding. MIG welder use a wire welding electrode on a spool feed automatically at a constant pre-select speed, so we can adjust the power from the machine. Okay, shielding gas. The shielding gases are two types, inert or semi-inert. The shielding gases that are used in MIG welding, argon and helium, are inert and most effective shielding gas used in the MIG welding. Pure argon and helium is used to weld non-ferrous materials. The semi-inert gases are the mixture of carbon dioxide, nitrogen, hydrogen, and oxygen in the argon.
Hi, my name is Shazrin Natasha binti Uzi, anemometri 15 DKM 21F1043. What is electrode polarity? Polarity refers to the electrical conditions determining the direction of the current flow relative to the electrode. Generally, for graphite electrodes, a positive polarity gives a better wear condition, whereas negative polarity gives better machining speed. Okay, next. What are the types of welding current? There are three different types of current used for welding or alternating currents: AC, direct current electrode negative DCEN, and direct current electrode positive DCEP. Which type of current and polarity is most commonly used for GMAW? Positive polarity. Positive polarity is recommended for GMAW, MIG welding, because 2/3 of the current is generated. An exception is when using the some plug cord wires and a formulated for negative polarity. The same goes for some hard facing wires. What current and polarity is used for MIG welding? MIG welding is carried out on DC electrode welding wire. Positive polarity DCEP. However, DCEN is used for higher burn off rate with certain self-shielding and gas share wires. DC output power sources are of a transformer rectifier design with a flat characteristic constant voltage power sources. What are the three welding current polarity? There are three main types of polarity. First, direct current straight polarity. Second, direct current reverse polarity. And the last one, alternating current polarity. Effect of polarity on the welding process. Polarity matters greatly in welding because choosing the right polarity affects and strength and quality of the weld. Using the wrong polarity will lead to loss of spatter, bad penetration, and a lack of control of your welding acts. Advantages and disadvantages of GMAW. Advantages. First, high deposition efficiency when used in certain transfer models. All electrode weight is posited into a weld, whereas with other processes you must account for start loss plug and flux or slack. It's second, not slack too cheap as compared to SMAW and FCAW. Third, the process can be used on thin materials with relative ease if properly set. GTAW can also be used on thin materials, but in many cases, such as auto body, GMAW wins hands down. Disadvantages. First, requires a fire feeder which is difficult to move and can sometimes be a maintenance or repair burn. Second, needs shielding gas, so welding in windy conditions can be difficult. Third, no slack system to so out of position welds are sometimes more difficult. Thank you.
Nama saya Tirun Venkatesam, anak lelaki Ragunamu. Nombor metrik saya ialah 15 DKM 21F 1051. Today I am present 7.4.1a, that is gas tungsten arc welding. What is GTAW? GTAW is gas tungsten arc welding, also referred to as TIG, tungsten inert gas. In TIG welding, tungsten inert welding, a tungsten electrode hits the metal you are welding, and gas, most typically argon, protects the weld from airborne contaminants. TIG welding uses a non-consumable tungsten. Filler metal, when required, is added by hand, and shielding gas protects the weld and tungsten. Okay, now we look at safety precautions. Electric shock can kill. We should always wear dry insulating gloves. Insulate yourself from work and ground. Do not touch live electrical parts, and keep all panels and covers securely in place. Second one is fumes and gases can be hazardous to your health. Keep your head out of the fumes. Ventilate area or use breathing device. And welding can cause fire or explosion. Do not weld near flammable material. Watch for fire. Keep extinguisher nearby. Do not locate unit over combustible surfaces. Arc rays can burn eyes and skin. Noise can damage hearing. These are the next safety precautions. So wear welding helmet with correct shade of filter. Wear correct eye, ear and then hot parts can cause injury. Allow cooling period before touching welded metal. Magnetic fields from high currents can affect pacemaker operation. Flying metal can injure eyes. Welding, chipping, wire brushing, and grinding cause sparks and flying metal. Wear approved safety glasses with side shields. And now look at equipments. We have lots of equipments, and those are welding power source, tungsten electrode, filler metal, welding torch, high frequency unit, suppressor, and more. This is one of the equipment with a label. These are they got label for the equipment, and this is one of the equipment, and this is also one of the equipment. And now let's see the technique of basic of GTAW, gas tungsten arc welding. Arc length. Arc length normally 1 electrode diameter when arc length welding with a bale and electrode. When this welding with a pointed electrode, arc length may be much less than electrode diameter. This is electrode and this is workpiece. Gas cup size. Inside diameter of gas cup should be at least 3 times the tungsten diameter to provide adequate shielded gas coverage. Picture on right shows example of gas cup size and torch position. Electrode extension refers to distance to the tungsten extends, but beyond the gas cup. May vary from flush with the gas cup to no more than the inside diameter of the gas cup. Manual torch movement. This is the tungsten without filler load, and this is tungsten with filler rod. Butt weld and stringer bait. Be sure to center weld pull on adjoining edges. When finishing a butt weld, torch angle may be decreased to aid in filler the crater. Lap joint. Pull is formed so that the edge of the overlapping piece and the flat surface of the second piece flow together. Torch angle is important because the edge will become molten before flat surface. Enough filler metal must be added to fill the joint as illustrated on the right. T-joint. Edge will heat up and melt sooner. Torch angle illustrated with direct more heat onto the flat surface. The electrode may need to be extended further beyond the cup in order to hold a short arc. Corner joint. Both edges of the adjoining pieces should be melted and the full cap on the joint center line. Sufficient filler metal is necessary to create a convex peak as shown. This is argon helium and argon helium mixtures. This argon is a good arc starting, good cleaning action, and good arc stability. Helium is faster travel speeds, increased penetration, difficult arc starting, and less cleaning action, and more. Argon or helium mixtures. Improve travel speeds over pure argon. Improve penetration over pure argon. Cleaning properties closer to pure argon. Improve arc starting over pure helium. Improve arc stability over pure helium. Moreover, arc cone shape more focused than pure helium. Arc voltage between pure argon and pure helium. Higher flow rates than pure argon. Costs higher than pure argon. Parameter. These are the parameter of aluminium manual welding alternating current high frequency stabilized. This is the guide to selecting a tungsten electrode based on the amperage range. Polarities. Direct current straight polarity. Tungsten electrode negative work positive used for mild steel, stainless steel, copper, and titanium. Direct current reverse polarity. Tungsten electrode positive work negative used for welding aluminum and heavy oxidized aluminum castings. Alternating current high frequency. It is used for AL and MG. High frequency also helps in oxidant cleaning. 7.4.1b. So advantage and disadvantages of gas tungsten arc welding. Advantages are welds more metals and metals alloy than any other processes. Disadvantages is lower filler metal position rates, high quality and precision, and disadvantage is good hand-eye coordination and requires skill. No sparks or spatter, brighter UV rays than other processes, no flux or slag, slower travel speeds than other processes, no smoke or fumes. Equipment's costs tend to be higher than other processes. That's all from me.
Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera. Saya Ikmah Haikal bin Abdullah, nombor matrik 19 DKM 21F1086. Hari ini saya akan membentangkan tajuk 7.5.1 welding defects. What is welding defect? Welding defects can be defined as the irregularities formed in the given weld metal due to wrong welding process or incorrect welding patterns, and etc. The defect may differ from the desired weld bit shape, size, and intended quality. Welding defects may occur either outside or inside the weld metal. Some of the defects may be allowed if their effects are under permissible limits, but other defects such as cracks are never accepted. Ada beberapa jenis welding defects, iaitu terbahagi kepada dua, external welding defects dan internal welding defects. Antara external welding defect ialah weld crack, undercut, spatter, porosity, overlap dan crater. Internal welding defect pula ialah slight inclusion, incomplete fusion, necklace cracking, and incompletely filled groove or incomplete penetration. Okey, sebelah kiri kita adalah jenis-jenis welding defect yang berbeza. Okay. External welding defects. Yang pertama, weld crack. Weld crack terbahagi kepada hot crack dan cold crack. Maksud weld crack this is most unwanted defect of all the welding defects. Welding cracks can be present at the surface inside of the weld material or at the heat effect zone. Crack can also appear at different temperatures seperti mana saya cakap tadi, hot crack and cold crack. Cause of weld crack. Okay, saya ambil dua contoh punca berlakunya weld crack, poor ductility of the given base metal dan the presence of residual stress can cause a crack on the weld metal. Prevention for the weld crack using appropriate materials may decrease the chance of crack. Preheating the weld and reducing the cooling speed joint helps in reducing crack. External welding defect yang kedua ialah undercut. When the base of metal melts away from the weld zone, then a groove is formed in the shape of a notch. Then this type of defect is known as undercut. It reduces the fatigue strength of the joint. Punca berlakunya ialah if the arc voltage is very high, then this defect may occur. Yang kedua, if we use the wrong electrode or if the angle of the electrode is wrong, then also the cause. Prevention, reduce the arc length or lower the arc voltage. Second, keep the electrode angle from 30 to 40 degree with the standing leg. External welding defect yang ketiga adalah spatter. When some metal drops are expelled from the weld and remain stuck to the surface, then this defect is known as spatter. Punca berlakunya ialah high welding current can cause this defect. The longer the arc, the more chance of getting this defect. Incorrect polarity, improper gas shielded may also cause this defect. Prevention, reducing the arc length and welding current. Ataupun using the right polarity and according to the condition of the welding. Yang keempat, porosity. Porosity in the condition in which the gas or small bubbles get trapped in the welded zone. Punca berlakunya ialah it occurs when the electrode is not coated properly. Using a longer arc may also increase its chance. Okay. Prevention, proper selection of the electrode, decreasing the welding current, using smaller arc, and slowing the process to allow the gas to escape. Selanjutnya yang kelima, external welding defect ialah overlap. When the weld face extends beyond the weld toe, then this defect occurs. In this condition, the weld metal rolls and forms an angle less than 90 degrees. Okay, punca berlakunya improper welding technique by using large electrodes. Okay, prevention, using a proper technique for welding and use small electrode. Yang keenam, crater. It occurs when the crater is not filled before the arc is broken, which causes the outer edge to cool faster than the crater. This causes a stress and then crack is formed. Puncanya adalah incorrect touch angle, use of large electrode, improper welding technique. Prevention, using a proper touch angle may reduce the stress on the metal. Using a small electrode may also decrease the crater. Use a proper technique. Okay, sekarang kita berpindah pada internal welding defect. Yang pertama, slack inclusion. If there is any slack in the weld, then it affects the toughness and metal weldability of the given material. This decreases the structural performance of the weld material. Slack is formed on the surface of the weld or between the welding turns. Causes slack is formed if the welding currently density is very small, as does not provide the required amount of heat for melting the surface. Prevention, increase the currently density. Yang kedua, incomplete fusion. Incomplete fusion occurs when the welder does not accurately weld the material and the metal pre-solidifies which leads to a gap which not filled with the molten metal. Causes it occur because of the low heat input. Second, when the weld pool is very large and runs ahead of the arc. Prevention. Increasing the welding current and decreasing the travel speed helps in removing the chance of incomplete fusion. Yang kedua, reducing the deposition rate. Internal welding defect yang ketiga ialah necklace cracking. It occurs in the use of electron beam welding where the weld does not penetrate properly. Therefore, the molten metal doesn't flow into the cavity and results in a cracking known as necklace. Puncanya, improper welding technique, and it occurs in materials such as nickel-based alloys, and stainless steel, carbon steel, and tin alloys. Prevention, using a proper welding technique reduces the chance of necklace cracking. Using proper materials of welding. Internal welding defect yang keempat, incompletely filled groove and incomplete penetration. This defect occur only in the butt weld, where the groove of the metal is not filled completely. It is also called as incomplete penetration defect. Puncanya, less deposition of the weld metal, use of improper size of the electrode. Prevention, more deposition of the weld metal, use the proper size of the electrode by using a proper welding technique.
Nama saya Muhammad Nazmi Syakrin bin Zahari. Saya akan terangkan pasal investigate distortion in welding and how to minimize distortion. First, what is distortion? Any unwanted physical change or departure from specifications in a fabricated structure or component as a consequence of welding. Main cause of distortion, non-uniform expansion and contraction. Shrinkage due to plastic thermal strain of the weld metal and base metal during the heating and cooling cycle. Internal stress formed in base metal due to remove restraint given to weld by fixed components surrounding. So, both welding process and produce and material properties. Effect of distortion complicate future fabrication, reduce application of the structure, high cost of rectifying deformation. Touch of welding distortion. Transverse shrinkage, angular distortion, longitude distortion or bowing or bending. Rotational distortion, buckling and twisting, longitudinal strip change. During the welding process, the weld metal and the adjacent base metal will expand and contract the heating and cooling circuit. During this cycle, it is inevitable that some distortion will also due to the movement of the metal. So, how to minimize distortion? First, size of weld. It's important to avoid overwelding. The bigger the wheel, the greater the shrinkage that will occur. Second, intermittent welding. Intermittent welding, rather than continuous weld, will minimize the amount of weld metal used. Yang ketiga, fewer wheel passes. During the welding process, shrinkage will accumulate with every wheel pass. Yang keempat, welding placement. It's important to place weight near the natural edges to center of the part. Yang kelima, balance around the natural edges. Balancing your weld around the natural edges of the product and wheel on both sides of the plate in order to offset on one shrinkage or which another. Yang keenam, backstab welding technique. Using the backstab welding technique involves general welding left to right, while depositing its bed segment right to left. For setting part, throw a few trial wax at the beginning. You can determine the amount of preset required for ferro width. Yang ke-8, alternate welding sequence. A careful turn welding sequence can help minimize distortion. And clamping. Using clamp will lock part into the desired position and hold them until the welding is finished. Pinning. Pinning is the process of striking a product with the back part of a hammer. And seterusnya, thermal stress relief. Another technique to relieve stress in order to minimize distortion is thermal stress relief. And seterusnya, minimize welding time. The longer the welding process takes, the greater the chance for distortion. And 13, water-cooled jig. Using a water-cooled jig is an effective tool in minimizing distortion in sheet metal welding. And last sekali, strong bed. A strong bed is a tool used to control distortion during butt welding of plate. Clips are welded to the edge of one plate, while weights are driven under the clip to force the edge into agreement while holding them during welding. This tool can help reduce distortion in this specific welding process. Itu saja daripada kami. Terima kasih.